Hello everyone, my name is Prakriti P. I'm a second year computer science engineering student studying in Sri Venkateshwara College of Engineering, and today I'm here to give a presentation on Boolean algebra versus general algebra in the subject digital design and computer organization. So today I'll be giving an introduction about what is the meaning of algebra, and then I'll be going into the main topic, which is the Boolean algebra and its examples, and general second main topic, which is general algebra and its examples, and then I'll be comparing both the Boolean algebra as well as the general algebra, and I would like to conclude my presentation. So this is basically the introduction of the slide. Here I'll be explaining about what is algebra. So algebra is basically a branch of mathematics which deals with symbols and rules which are used for manipulating these symbols. There are mainly it's a fundamental part of various algebra is basically a fundamental part of various fields which includes mathematics, physics, engineering and computer science. It mainly has two essential branches, which is Boolean algebra and general algebra. These two, Boolean algebra as well as general algebra, have some similarities, but they serve distinct purpose and they have different applications to serve. So, what is Boolean algebra? Boolean algebra is basically named after a mathematician who is known as George Boole, and it is a main branch of algebra which deals with only by taking two values at a time, which is true and false, or it can take only two values, which is zeros and ones. So, one resembles true and zero resembles false. So it is widely, this Boolean algebra is widely used in digital electronics subjects like computer science, logic circuits, and these Boolean algebra operations also include the AND, OR, NOT, XOR, and NAND gates, which are the fundamental building blocks for designing digital circuits. And Boolean algebra also follows specific rules and laws, such as commutative, associative, and distributive laws, which govern the manipulation of Boolean expressions. So here are some of the examples of Boolean algebra. So the first example says a plus a dash is equals to 1. Here it is an OR operation which complement equals to 1, and here the second example is a into a dash is equals to 0. Here it is an AND operation and its complement is equal to 0, and the third example is a into 1 is equals to a. Here it is an AND operation and it 1 equals to the operand itself. So, general algebra, the second main topic of algebra, which is general algebra. So, general algebra basically encompasses a broader range of algebraic structures and operation, which means that it deals with variables which can take values from any set, such as real numbers, complex numbers, matrices, vectors, and more, many more. So, general algebra also includes various algebraic structures such as groups, rings, fields, vector spaces, and algebras, which also with its own set of rules, which this also follows rules and regulation as we saw in Boolean algebra, and but here it has its own rules, set of rules and properties. So the general algebra is a fundamental in mathematics which has applications in diverse areas such as abstract algebra, linear algebra, algebraic geometry, and cryptography. Here are some of the examples we can see in the slide for general algebra. So the first one is a commutative property of matrix multiplication, which is A into B is equals to B into A. And the second example is A plus B in the bracket into C is equals to A into C plus B into C. Here it's a distributive property of matrix multiplication over addition. So now I'll be comparing both the general algebra as well as the Boolean algebra. We'll see how it is different and similar at the same time. So first I'll be seeing about the scope of variables in Boolean algebra and general algebra. So the Boolean algebra, the variables can only take two values. As we discussed earlier, it can take only two values in Boolean algebra, which is true or false. In general algebra, variables can take any values from any set, which includes how many our values it can take. So it can take real numbers, complex numbers, matrices, etc. So this is the main difference between the Boolean algebra as well as the general algebra. So what are the applications of Boolean algebra and general algebra? So where can this Boolean algebra and general algebra mainly be used is for first of all, the Boolean algebra is extensively used in digital electronic subjects like computer science and logic circuits, whereas general algebra is it is an it can be applied in diverse areas such as in subjects such as mathematics, physics, and it can be used in engineering, cryptography, and computer graphics. Operations. So Boolean algebra primarily focuses on logic operations such as AND, OR, NOT, and XOR, etc. Whereas general algebra involves a wide range of operations depending on the algebraic structure, which includes addition, multiplication, exponentiation, etc. So now I would like to conclude by saying that Boolean algebra as well as general algebra are basically both essential branches of mathematics which has different distinct applications and scopes. While Boolean algebra is mainly specialized for dealing with binary logic, whereas general algebra is mainly used for broader framework for studying algebraic structures and operations with variables from various sets. So understanding the difference between these two branches of algebra is very crucial for applying them effectively in different problems. So this was the end of my presentation, and I would like to thank you guys for watching it till the very end. See you in my next video.